So this lesson, we're taking a look at the slope-intercept form of a linear equation. This is what I have written out here as y equals mx plus b. Perhaps you've heard of it. So to go over the pieces, the important parts here, because the reason we write in this form is to be able to graph our line. So in this case, the m and b are going to be two values that are going to be very important to helping us graph. So slope, which is m, just denoted by m, again means rise over run. And it's just a way to count from point to point to get the slant of a line. So a slope overall just pretty much tells us how slanted a line is. It's always going to be in this fraction of rise over run. I'm going to have a separate lesson altogether discussing slope that you might want to take a look at before you look at this one. B, if you've already looked at my video or are familiar with it, but my video on horizontal and vertical lines, I talked about what B is representing. But B is the y-intercept. This is the y value of the point where the line crosses the y-axis. Remember, our points are always these ordered pairs x comma y. So it's always going to be this y value of the point where our line crosses the x-axis. On the next page, I'll go over 4 or 5 steps on how to graph a line, but these are the two important pieces we need. And I just want to write out a little example here, or a few. This is an example of an equation that's in slope-intercept form. Here, our slope is the fraction. It's always going to be the number in front of x. Most of the time it is a fraction. We can turn any number into a fraction, even if it isn't. But here our slope is 1/3, and our y-intercept, b, is 2. And I'm going to show you what important part each of these play when graphing a line. So let's take a look at how to graph the 4 or 5 steps that I'll write out here on how to graph a line that is in slope-intercept form. So graphing a line from slope-intercept form. And I want you to think about the name too. The slope, which is what we saw, m, and then the intercept means it's the y-intercept. So it's very straightforward with the name. When we're looking at this form, we're looking at the slope and then the y-intercept. So step 1 is to identify both the slope and the y-intercept. M, which is our slope, and B, which is our y-intercept. I'm just going to abbreviate this way. Step 2 is we're going to start by plotting the y-intercept on our graph. I like to say we begin with B. So we want to plot the y-intercept on the y-axis. Step 3 is we are going to move with M. Move starts with M, so we're going to move with M. Begin with B and move with M. And all this means is use our slope to plot a few more points. Okay, we can get this in 4 steps then. And then step 4, draw a line. If you're doing this on paper, make sure you're using a ruler. I always tell my students use a straight edge. But 4 is just connect the dots. We want to draw our line through these points. All right, so let's take a look at an example of a couple of these. So I just want to start with the example that I just had. It was 1/3 x plus 2. So again, notice I said with this one, our slope is 1/3, and our y-intercept b is 2. So I'm going to start with b. I'm going to go over here to my graph. I'm going to plot b, which is 2 on the y-axis. So I'm putting a point right here at 2 on our y-axis. Next, I'm going to move with our slope. So let me rewrite this right next to it here. So notice both of these numbers are positive. So 1 is the rise. And if it's positive, I always want to move up or down first. In this case, I want to move up. And then 3 is the run. So when our run is positive, I want to move to the right. So that means I'm going to use a different color here, just green. I'm going to count up 1 square and then 3 to the right. 1, 2, 3. And then this is where I'm going to put my new point. So I'm climbing up 1 over 3, just like walking up steps. I'm going to repeat it one more time. I'm going to go up 1 and then over 3. I'm even going to put like arrows here. So I'm going up 1 and then over 3. And then that's where my next point is going to go. Now keep in mind, a line goes forever in both directions. So let's say I'm graphing and I just ran out of room as I continue to go up 1 and 3 to the right. So I can also go just in the opposite direction. From my original point here at 2 on the y-axis, I can go down 1, which is the opposite of going up. And instead of going right 3 to the right, I can go 3 to the left. And I can put my other point here. Now notice all these points are still going to line up. And I'm going to draw a line here as I go through them. Or if you're graphing on paper, you can take your ruler and just start to line them up. And then here is the line. Of y equals 1/3 x plus 2. So this x and y that are staying the variables, this is just representing all the points on here. So for instance, if I took a look at this point, going from the origin here, I'm going to go 6 to the right and then 4 up. So the ordered pair 6, 4 would satisfy this equation, meaning if I were to substitute in a 6 here, I'll just show you right below. If I'm using y equals 1/3 x plus 2, and I'm going to plug in 6 for x and 4 for y, 4 is equal to 1/3 times 6 plus 2. So 1/3 of 6 is 2, and 2 plus 2 is 4. So when you're ever asked to verify if a point is on a line, all you have to do is take the ordered pair, substitute it in carefully, the y value, the x value, and you should get a true statement here. So 4 is equal to 4. So I know that the ordered pair 6, 4 is on this line. And that's another way to indicate if I graphed my line correctly. So let's take a look at a few more examples. Okay, so here's a few more examples. I want to take a look at this first one. Notice it is y equals -2/3 x. So again, step 1 was just to identify our slope and our y-intercept. Here our slope is always the number, sign included, right in front of x. So here our slope is -2/3. And then our b, notice there's no number after it. So our b, when we don't see a plus or a minus, any other number after it, our b is just going to be 0. So again, when I go to start here, my b, I want to begin with b for my second step. I'm going to go right to the origin. That is where y is equal to 0. Now, anytime we see a negative slope, if you remember the direction of a line that has a negative slope, it is going to be in this downhill direction from left to right. Anytime we see a positive slope, it's going to be an uphill direction. So with this, I'm going to associate this negative sign with the 2. So my rise is going to be a -2, which means I want to count down 2 and 3 to the right from this point. So I'm going to count, going right from my origin here, I'm going to count down 2 blocks, down 2, and then 3 to the right, and then I'm going to make my new point. And then if you notice, if I were to just connect these 2 points, look at that downhill direction from left to right. I'm going to continue again. I'm going to go down 2 squares and then 3 to the right, make another point. I can continue this until I run out of graph paper. And again, like I mentioned on the first example, I can also go in the complete opposite directions of both of these. I can go up 2 and 3 to the left. And we know we're doing this correctly because the points will still line up. I can go up 2 more and then 3 to the left. And then from this, I can connect my points. All right, so here is my first line. I'm going to call this number 1. If you want to go ahead and try the next 2, go ahead and pause the video and then return to check your work. But in number 2, my slope is 3. Now, if you notice, this is not a fraction, but I can make any number of fractions simply by putting it over 1. So my slope is 3, or 3 over 1. And now my y-intercept, again, keep the sign, is a -4. So I'm going to begin with b. I'm going to go down to -4 on my y-axis. My slope is positive, so my line is going to be going uphill left to right. In all of these examples, we're either going to get a line that goes uphill left to right if it has a positive slope, or downhill left to right if it has a negative slope. I have another lesson, separate lesson on horizontal and vertical lines that you can view, and you can see the differences between these. So here, if my rise is +3, I'm going to go up 3. We always want to go up or down first when we're talking about slope. And then my run is +1. So from this point down here at -4, I'm going to climb up 3 squares and then 1 to the right. I'm going to repeat that again, up 1, 2, 3, 1 to the right. Remember, I can also go in the opposite direction. I can go down 1, 2, 3, and 1 to the left. So there is my points that are lining up, drawing a line here. This is our second equation of y equals 3x minus 4. So we'll take a look at one more example. Here in example 3, y is equal to -5/4 x plus 7. Our slope is a -5/4. Notice I'm going to put the negative up top. I just think it's always easier if we do that. And then our b, our y-intercept, is at 7. So I'm going to go up, again, begin with b. I'm going to go up to +7 on our y-axis. So I'm right up here. And now my slope is negative, so again, we will be expecting this downhill direction as we go from left to right. If my rise rather is a -5, I'm going to go down 5 and 4 to the right. So from this point up here at 7, I'm going to go down 5 squares, down here to 2, and then over 4 to the right. And again, I can repeat this down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. Now here, if I try this, going back up to the 7, I can go up 1, 2, 3, 4, 5. But if you see, I'm off of the paper here. So in this case, continuing just in this downward direction, this is my third example. So this line right here is y equals -5/4 x plus 7. So just some few examples going over the steps on how to graph from slope-intercept form. I will be making another video just showing you how to rewrite equations in slope-intercept form, because not everything will be given to us in that form. Again, if you have any questions, please feel free to email me at help@thealgebratutor.com in order to request a specific lesson. Thank you.